Hello again. In the previous lesson, we graphed the other trigonometric functions, tangent, secant, cosecant, and cotangent. In this lesson, we're going to work with trigonometric identities. An identity is an equation that is true for all values where both sides are defined. So the goal is not to solve for x. The goal is to rewrite one side until it matches the other side. So let's begin, first of all, with the quick rules. So here we have the reciprocal identities. So the reciprocal identities are cosecant theta, which equals 1 over sine theta, secant theta over 1 over cosine theta, cotangent theta over 1 over cotangent theta. So quotient identities, we have tan theta, which equals sine theta over cosine theta, cotangent theta, which equals cosine theta over sine theta. Pythagorean identity is sine squared theta plus cosine squared theta, which equals 1. And then we need to verify identities by rewriting one side until it matches the other side. That's the key idea. All right. So again, when we verify or simplify identities, we need to rewrite everything in terms of sine and cosine as much as humanly possible. Okay. Let's begin by looking at example number 1. Example number 1, it says rewrite each expression using only sine and cosine, right? And we're going to use A, B, and C. So part A, we need to start with secant theta, tan theta. Now, essentially what we're going to do is we're going to rewrite secant and tangent using sine and cosine. Okay, so secant theta is equal to cosine theta as a denominator of 1. And then tan theta is equal to quotient of sine theta over cosine theta. Now we need to substitute, okay? So secant theta times tan theta, which is what A is secant theta times tan theta, would be 1 over cosine theta times sine theta over cosine theta, and we would be multiplying that, okay? When we multiply that, remember the product of fractions is to multiply the numerator and the denominator. So when we multiply this straight across, we ended up with sine theta over cosine squared theta, right? Because cosine theta times cosine theta would be cosine squared theta. Okay, so the answer is sine theta over cosine squared theta. Now we need to rewrite B. So B is cosecant theta, cotangent theta, right? So cosecant theta is 1 over sine. And cotangent theta is cosine theta over sine theta. So computing this would end up with cosine theta times cotangent would be the multiplication of both of these two. So 1 over sine theta and cosine theta over sine theta which would be cosine theta over sine squared theta. Okay. Next, we need tan theta divided by secant theta. Okay. So we have secant theta and we also have tan theta. And so those are going to be, in this case, we're going to have quotient. Okay. So again, we're looking for tan theta, which is sine over cosine, and we're going to divide that by secant theta. Right. So the way that would look is tan theta divided by secant theta would be sine theta or cosine theta divided by secant theta is 1 over cosine theta. And remember, when you have a complex fraction, you multiply by reciprocal. So this would be sine theta, cosine theta, multiplied by the reciprocal of this. So this would be cosine theta divided by 1. Multiplying straight across, we end up with the cosine theta's simplifying, right, or reducing, and then we end up with sine theta over 1, which simplifies to sine theta. Okay, so here is A, B, and the answer to C. So when everything is rewritten in sine and cosine, the simplification becomes much, much easier. All right, let's continue. Now, when we use Pythagorean identities, it says given sine theta equals 5 over 13, and theta is in quadrant 2, find cosine and tangent theta. Okay, so we're given some values. We're given sine. Sine is y over r, or opposite over hypotenuse, right? Sine is the opposite over the hypotenuse. So essentially, if sine theta is equal to 5 over 13, then we know the opposite is 5, the hypotenuse is 13. So using the Pythagorean theorem or Pythagorean identity, which is sine squared theta plus cosine squared theta, that equals 1. So we need to substitute sine theta and make it 5 over 13 squared. Right? Because sine theta is 5 over 13, so we're going to square that. And we're going to add cosine squared theta equals 1. Then once we square this, that'd be 25 over 169. Then we would write our problem equals 1. And then we're going to subtract this to both sides. When we subtract, we end up with cosine squared theta. And that's going to be equal to, if I went ahead and changed the denominator, I would have to make this 169 over 169. So I'm going to go ahead and jump and do that. 169 minus 125 divided by 169. Okay. So that's just 1. So if I change this to 169 over 169, that's still the same as 1. Then computing this, I would end up with 144 over 169. Now, what we can do is we can take the square root now because we have we have cosine squared theta, which equals 144, 169. So we can take the square root of both sides, right? That'll tell us what cosine theta is. And remember, when you have a radical like this, there's a couple ways you can do it. You can make, we can do it like this. Or you can, simplify it. There's a couple ways you can, play with it. It just so happens that these are perfect squares, so this will simplify to plus or minus 12 over 13. Now it says use the quadrant. Okay, so we're in quadrant number 2. So theta being in quadrant number 2, we know that the cosine is going to be negative. Okay, remember cosine theta, sine theta is the x and y. So again, if you're over here in Q2, the x is going to be negative, the y is going to be positive. Okay, so the cosine theta is negative 12 over 13. Now we need to find tan theta. Okay, and I probably should have left that space for that. But tan theta is sine theta over cosine theta. So essentially, what that would be is the sine. And so sine, let's see, would be this, right? Sine theta would be 5 over 13. That's 5/13 divided by cosine theta, which is what we found here, which is negative 12 over 13. So when we simplify this, remember you're multiplying by the reciprocal. So this would be 5 over 13 times 13, 12. So again, the 13s would offset, left with negative 5 over 12. Okay, so the final answers are cosine theta is negative 12 over 13, and tan theta is negative 5 over 12. Okay, so the identity gave us the size of cosine, and then the quadrant gave us the sine. Now pause and try the bottom. So it says simplify 1 minus cosine squared theta divided by sine theta, and then state the identity used. So we want to start with that equation, and then we need to use the Pythagorean identity. Okay, so we have sine squared theta plus cosine squared theta equals 1. If we subtract cosine squared theta from both sides, watch what happens. We subtract it from both sides, we end up with sine squared theta equals 1 minus cosine squared theta, right? Notice this is that. See that? Okay. Now, what we can do from that point, from here, we can replace the numerator with this, right? So the numerator, so we have 1 minus this divided by sine theta. We can simply replace this expression with this because this is equal to that over here, right? So this would be sine squared theta divided by sine theta. Now we can simplify that. So again, this is like having twice of these. So after reducing it, we would be left with sine theta. So the answer is sine theta And the identity that we used is Pythagorean identity. Okay, let's continue. Example number 3. Verify the identity. So we have parentheses 1 minus cosine squared theta divided by sine theta times cosine theta equals tan theta. Show each algebraic step. Okay. Okay, so again, let's see. When verifying an identity, don't move terms back and forth like it's an equation, right? Like don't just, all right, well, I'm gonna, you know, extract this and then I'm just gonna move some terms over and see what I can do with it. Um, Instead, start with one side and rewrite it until it becomes the other side. Okay. So what I'm gonna do is I'm gonna start with the left-hand side. All right, so we have 1 minus cosine squared theta divided by sine theta cosine theta. Okay. So 1 minus cosine squared theta divided by sine theta times cosine theta. So I want to use the Pythagorean identity again because I notice it up here, right? So what I'm going to do is I'm going to write the problem that we looked at earlier, which was this right here. So remember, if I subtract cosine squared theta to both sides, I'm going to end up with sine squared theta, okay? So in an effort to keep space, I already know that this is going to be sine squared theta, all right? So this is sine squared theta divided by sine theta cosine theta, okay? So I've replaced the numerator essentially with this, and then my denominator remained the same. Now I can simplify this. One factor of sine is going to cancel from the numerator and the denominator, leaving me with sine theta cosine theta, right? Now we can use the quotient identity, right? Because sine theta over cosine theta is equal to tan theta, because tan theta is sine theta over cosine theta. Okay, so this one checks out. So the way I can write it essentially is the left side becomes the right side. So 1 minus cosecant squared theta divided by sine theta times cosine theta is equal to tan theta, and the identity checks out. Okay. Example number 4. Choose an identity strategy. So it says verify secant squared theta minus tan squared theta equals 1. Then explain why this is equivalent to sine squared theta plus cosine squared theta equals 1. Okay. So again, I want to start with the left-hand side of this expression here, this equation. And I'm going to rewrite secant and tangent using sine and cosine. So if you recall, secant squared theta is a reciprocal. So secant squared theta is the same as 1 over cosecant squared theta. Okay. And tan squared theta is the same as sine squared theta over cosine. Okay. So I'm going to substitute that data information. So this becomes this, and I'm going to subtract that from that. Okay. So the way this would look is 1 over cosine squared theta minus sine squared theta divided by cosine squared theta. Notice the denominators are already the same. So what this essentially looks like is 1 minus sine squared theta divided by cosine squared. Okay. Now, I can use the Pythagorean identity over here because if you recall, the Pythagorean identity is sine squared theta minus cosine squared theta. So just imagine moving this over here by subtraction. That would leave cosine squared theta equaling 1 minus sine squared theta. So 1 minus sine squared theta is the same as cosine squared theta. Okay. FYI. So I can replace the numerator with cosine squared theta. That would be cosine squared theta in the denominator. What does that simplify to? 1. So we have verified that secant squared theta minus tan squared theta is equal to 1 by computing this. Let's see. And then it says, show that this is equivalent to sine squared theta plus cosine squared theta equals 1. So what we can do, let's see. How do I want to approach this problem? Let's see here. Okay, so in order to, it says, then explain why this is equivalent to sine squared theta plus cosine squared theta. So in order to compute this, we need to divide both of these terms by cosine squared theta. Okay, so the way this would look is we had sine squared theta plus cosine squared theta equals 1. What we'd have to do is divide both sides by cosine squared theta. So dividing both sides by cosine squared theta. Right? What we would end up getting if we simplify is sine squared theta over cosine squared theta is the same as tan squared theta, right? Tan squared theta would be this would be the left hand side, and then cosecant squared theta divided by that would be plus 1. And then notice we have 1 over cosecant squared theta, which is the same as secant squared theta, right? Secant squared theta is the same as 1 over cosine squared theta. So notice that. Now, if we rearrange this equation, right, if we brought this over here, or let's just say if we brought this over here, that'd be easier. We'd have 1 equaling secant squared theta minus tan squared theta. And that equals 1. So notice, so secant squared theta minus tan squared theta is equal to 1 is essentially just another form of the same identity trigonometric function known as the Pythagorean identity. Okay. Common mistake. A student cancels sine theta from sine theta plus 1 divided by sine theta and gets 1 over 1 plus 1. Explain the error. So the mistake is essentially canceling across addition. You can only cancel common factors, not pieces of a sum. So the numerator is sine theta plus 1. Okay, the numerator. So that is a sum. And then the denominator is sine theta, right? So essentially, that's sine theta over sine theta plus 1 over sine theta. So there is no common factor multiplying the entire numerator. So we cannot cancel this sine theta from only one term. Okay. Now, essentially, it's incorrect to say sine theta plus 1 divided by sine theta is not equal to 1 over 1. The correct way is to split the fraction. Okay. So the correct way is to look at it like this: sine theta divided by sine theta plus 1 over sine theta, right? That's the best way to look at this problem so you can see what it actually looks like. And then sine theta over sine theta is the same as 1. And then 1 over sine theta is the same as cosecant theta because that's a reciprocal. Okay. So the correct answer is actually 1 plus cosecant theta. And the rule is simple. You may cancel common factors, and but you may not cancel across addition or subtraction. You can't do that. Okay. So the final review is that reciprocal identities you need to memorize and commit them to memory. Secant theta is 1 over cosine theta. Tan theta is sine over cosine theta. There's a quotient. Cosecant theta is 1 over sine theta. And then, as a matter of fact, I wrote those up here. Okay. So, as a matter of fact, you can pause the video and read these quick rules, but you need to study these. You need to familiarize yourself with them, play with them a little bit, practice them, and you'll become a master at it. All right. I hope to see you in the next one. Take care.